Okay, let's dive into this. Welcome to this explainer. Today, we're embarking on a bit of a code detective story. We're going to track down and solve two notorious React Storybook bugs that have literally been blocking our development team. You know the drill, right? You've got your browser completely freezing up when you're just trying to test a component, or you're staring at this incredibly frustrating blank white canvas where your UI is supposed to be. Well, if you've been there, you're in exactly the right place. So, here is our roadmap for today. We'll start with Section 1, the storybook rendering nightmare. Then, Section 2, fixing the infinite loop. Section 3, solving the blank canvas. And finally, Section 4, the new best practices. Let's get right into it with Section 1, the storybook rendering nightmare. Now, if you write React code, you absolutely know this one. It's a deeply familiar and incredibly frustrating pain point. Maximum update depth exceeded. Basically, it means React is having a full-blown panic attack. It gets caught in this vicious cycle of unmounting a component, remounting it, updating the state over and over and over again until it hits a hard limit. Next thing you know, your sleek, fast browser is turned into a completely frozen brick. Not fun. It's a scenario I think we've all pictured. You're just trying to test a simple modal, something like the agent approval modal body component. But the second you load Storybook, bam, the console is just bleeding red with errors. The story tree is desperately trying to mount, it's firing off side effects, tearing itself down, and then starting the whole shebang all over again. Your components are trapped in a D-loop, and honestly, your productivity drops to absolute zero. Which brings us to Section 2, fixing the infinite loop. Now, what's really interesting about this is when we dive into the code, we actually find create memory router being called directly inside the preview.js decorator. And here, my friends, is the trap. Every single time that component renders, it runs that function and creates a brand new router object. React Router looks at it, assumes everything changed, forces an update, and boom, triggers the loop. The fix, though, is elegantly simple. We just wrap our root component in a stable memory router tag. It initializes exactly once, and just like that, the loop is broken. But plot twist, the router wasn't our only culprit. Inline object literals? Yeah, those act as hidden traps too. Passing theme overrides directly inside the component body actually creates a new memory object on every single render pass. So when the theme wrapper receives this brand new memory reference, it fires its internal effects repeatedly, calling setState and triggering yet another infinite loop. So what's the solution? Just pull that object out. Define a static constant like theme overrides above the component. Presto, the reference stays constant across renders. What we're really talking about here is an unstable reference. Think of React as a highly anxious, super literal manager. Even if the data inside an object or function looks exactly the same to you and me, if it has a new memory address, React panics. It throws its hands up, assumes the entire world has changed, and rebuilds everything from scratch. Keeping references stable is literally how we keep React calm, cool, and efficient. And this brilliantly illustrates the ultimate culprit in our infinite render mystery. When rendering the story explicitly as a JSX tag, Storybook generates a new story FN function reference on every single render. React looks at it and treats it as a brand new component type every single time. It completely destroys the DOM tree and rebuilds it. But by simply invoking it as a JavaScript function with curly braces, it directly returns the stable element tree. Now, React can reconcile the state smoothly without rerunning all those mount effects. Okay, so we've updated our imports, we stabilized our references, and those nasty red errors in the console are finally gone. The code is compiling beautifully. But wait, we're now faced with our second major mystery. Why are modals, like the chase payment modal body, completely invisible? The canvas is just a sea of blank white. Let's figure this out in Section 3, solving the blank canvas. So, the crucial point is, Storybook isn't magic, right? It can only display exactly what your story explicitly returns. Our legacy code was actually using custom hooks to inject a modal pop-up into a provider somewhere else, while the story itself was just returning null. Well, if you return null, Storybook draws nothing. It stays entirely blank. To actually visually test a component in the canvas, you absolutely must return the direct JSX component layout. It turns out there's a really reliable three-step formula to rescue our disappearing components, like the chase payment modal body, the coverage adjuster modal body, and the final rate modal body from the blank screen abyss. Step 1. Clean up the imports. Entirely remove those complex custom hooks and use effect statements. Step 2. Delete the hook execution inside the story itself. We really don't want to trigger application-level portal logic in an isolated visual test. And Step 3. Replace that dreaded return null with the direct JSX of the component, passing in the mocked props. Do that, and instantly, your UI comes bouncing back to life on the canvas. Let's move to Section 4 and see how this builds our new best practices. Here's the summary of the core architectural shifts we really need to adopt to maintain a stable, crash-free Storybook environment moving forward. First, always extract inline static objects and arrays to top-level constants to preserve memory references. Second, inside your decorators, invoke StoryFN as a function to maintain a stable element tree. Third, if you absolutely must use an effect to open a modal on mount, ensure your dependency array is strictly empty so it only fires once. And finally, for visual component testing, always return direct JSX in your stories. Never return null. I want to leave you with this thought as we wrap up this explainer. When we copy and paste without understanding why, we build on sand. We've seen today how just a tiny inline object or a simple JSX tag can literally bring a massive application to its knees if we don't understand how React manages memory. Mastering front-end development isn't just about making things look good on the screen. It is about deeply understanding the why behind reference stability. So take these new wiki practices back to your repos, but ask yourself, are we finally ready to write React stories that truly respect reference stability?